Welcome to the Deep Dive. Today, forget just hearing who might win a game. We're cracking open the code behind the prediction.
Exactly.
We've got this really interesting report from an AI called SmartBet. It's focused on an upcoming MLS match, DC United versus New York City FC.
That's right. It's the game on May 14th, 2025 at Audi Field.
And our mission today isn't just, to get the prediction itself. We want to dig into how this AI actually comes up with this forecast. The methods are surprisingly complex.
Yeah, the source is this Match Analysis report, the Gambler's Ruin project, and it's powered by SmartBet AI technology, specifically the MLS League version 4.0.3, so it's quite specific.
Okay, let's set the scene a bit. We're
Okay.
talking Wednesday, May 14th, 7:30 p.m. Eastern down in D.C. The report even gives us a feel for the weather. About 65 degrees Fahrenheit, partly cloudy, kind of humid, maybe a chance of showers, and a light breeze, SE 6 miles per hour. Typical spring evening on the East Coast, potentially.
Sounds about right. And weather can sometimes play a part, subtly.
And crucially, injuries. You always have to factor those in, right?
Yeah.
So for DC United, Jackson Hopkins is out. Ankle injury, no return date given, which is always tough.
Right. That uncertainty is tricky.
And for New York City FC, two key players listed. James Sands, also an ankle issue, but he's expected back maybe mid-July 2025. And Malachi Jones, lower leg injury. Again, no expected return date.
And we should keep those in mind because, as we'll see, this AI SmartBet actually tries to account for things like that.
Does it really?
Yeah, it's not just looking at past scores.
Okay.
So our goal today really is to get under the hood. What is SmartBet AI? What data does it use? What calculations does it run? And yeah, what does it predict for this DC NYC clash? It's a peek into, the data side of sports forecasting.
Okay, let's dive right in then. SmartBet AI, what is it in a nutshell?
Well, think of it as a pretty sophisticated prediction engine built just for Major League Soccer. What's interesting is its approach. It's kind of a hybrid.
Hybrid. How so?
It uses a statistical technique called Poisson regression, mainly to estimate how many goals each team is likely to score.
Okay. Expected goals.
Exactly. But then it also uses machine learning models classifiers to predict the overall match result, home win, draw, or away win.
So it's attacking the problem from two angles at the scoreline and the final result.
Precisely. And within that, there are several key pieces. The first one they mention is something called bootstrapped Poisson models.
Bootstrap Poisson. Okay, that sounds technical. Break that down for us.
Right. So the basic idea of Poisson regression, it's a statistical tool often used for count data, like the number of times something happens. In soccer, that's perfect for goals, right?
Makes sense.
So SmartBet uses this to get an initial estimate for expected goals. For this game, the standard Poisson model predicts 1.46 goals for DC United, the home team, and 1.23 goals for New York City FC, the away team.
Okay, 1.46 for DC, 1.23 for NYC FC. Straightforward enough. What does the bootstrapped part add?
Bootstrapping is a clever way to understand the uncertainty around those numbers. Instead of just one estimate, imagine running the goal prediction model, say, 1,000 times.
1,000 times.
Yeah, each time you slightly tweak the input data based on the original data. It simulates different possibilities. This gives you not just an average prediction, but also a sense of the range, a confidence interval.
So it tells you how much that prediction might wiggle around.
Exactly. So the report says the bootstrap prediction for DC United's goals is actually 1.49, but importantly, it comes with a 95% confidence interval of 0.0 to 4.0 goals.
Wow, so it could be anywhere from 0 to 4, realistically.
That's the range the model is confident about, yeah. And for New York City FC, the bootstrapped average is 1.23 goals, same as the basic Poisson, but again, with a 95% confidence interval, also 1.00 to 4.00 goals.
Okay, so bootstrapping gives us that crucial range, acknowledges the uncertainty, got it. What's the next component in this AI's toolkit?
Next up is something called a dynamic ELO rating. You might have heard of ELO ratings, maybe from chess.
Yeah, like a player ranking system.
It's the same principle for teams. It measures relative strength, and crucially, it updates after every single match based on the result and the opponent's strength.
And dynamic means?
Well, the report notes that this ELO system specifically adjusts for those injuries we talked about.
Oh, interesting. So Hopkins being out for DC and Sands and Jones for NYCFC, that actually impacts their ELO rating for this match.
That's what the report implies, yes. It makes the rating more reflective of the team's current potential strength. So for this game, DC United's ELO is 1,466.94. New York City FC's is a bit higher, 1,504.88.
So despite NYCFC's injuries, the ELO system still sees them as the slightly stronger side heading into this one.
According to this rating system, yes.
Okay, so we have goal estimates with uncertainty, and we have these dynamic team strength ratings. What else goes into the mix?
A whole bunch of things they group under contextual team features. This is where a lot of the typical soccer stats come in.
Right.
Things like recent form, points per game over the last few matches, expected goals, or XG, both for and against, home advantage, which is a real thing.
Definitely.
The injury count itself is a feature, how efficient teams are at scoring converting chances, and interestingly, market betting odds.
Wait, it uses the betting odds, like what Vegas thinks.
Essentially, yes. It takes the odds offered by bookmakers, converts them into implied probabilities, basically what the market collectively thinks the chances are, and uses that as another input feature for the models.
Huh. So it's leveraging the wisdom of the crowd, so to speak?
You could put it that way. The idea is that betting markets aggregate a lot of information, some of which might not be captured easily by other stats.
Okay, that's quite a range of inputs. Poisson for goals, ELO for strength, team stats, injuries, even betting odds. How does SmartBet pull all this together to actually predict, win, lose, or draw?
That's where the machine learning classifiers kick in. The report mentions 3 specific types: random forest, or RF, gradient boosting, specifically a popular version called XGBoost, and a multi-layer perceptron, or MLP, which is a type of neural network.
Okay, random forest, XGBoost, MLP. Sounds like some heavy-duty algorithms. What do they do with all that data?
Think of them as sophisticated pattern finders. They take all those features we just discussed, ELO, form, XG, injuries, odds, everything, and they learn from historical match data to identify the combinations that typically lead to a home win, a draw, or an away win.
So they're learning from past games.
Exactly. And the report mentions a couple of techniques they use in training these models. One is called SMOTE-D.
SMOTE-D?
Yeah, it's a way to handle imbalanced data. In soccer, draws might be less common than wins or losses in the training data. SMOTE-D helps make sure the model learns properly from all outcomes, even the less frequent ones.
Okay, makes sense. And the other technique?
Grid search. That's basically a systematic way to test different settings or hyperparameters for each machine learning model to find the combination that works best, that gives the most accurate predictions.
Right, tuning the engine.
Yeah.
So what did these individual models, RF, XGBoost, MLP, predict for this specific DC versus NYCFC game?
Well, this is quite interesting. According to the report, all 3 of them, the random forest, the XGBoost model, and the MLP neural network, they all independently predicted an away win.
All 3 pointed to New York City FC winning.
That's what the report states, yes. A consistent prediction across those different machine learning methods.
Wow, okay.
Yeah.
But the AI doesn't stop there, does it? There was something called a stacked ensemble.
Correct. A stacked ensemble. Think of it like building another layer on top.
Layering predictions.
Kind of. You take the predictions from those base models, the RF, XGBoost, MLP, and you feed those predictions into another model, a meta model. This meta model then learns how to best combine or weigh the predictions from the individual models. It's trying to be smarter than any single model by learning from all of them together.
Like a committee making a final decision based on the experts' reports.
That's a pretty good analogy, yeah. And the final prediction from this stacked ensemble model.
Let me guess. Away win.
You got it. The stacked ensemble also predicted an away win for New York City FC.
So that's pretty overwhelming from the classification side. 4 different machine learning approaches, all pointing to NYCFC. But what about those goal predictions we started with? The Poisson stuff.
Right, they bring that back in with the final component mentioned, the Monte Carlo simulation.
Monte Carlo, okay. Like the casino, randomness.
Exactly. It uses those predicted goal rates from the Poisson models, the 1.46 for DC and 1.23 for NYCIC as a starting point. Then it simulates the match thousands of times, in this case, 10,000 times.
10,000 simulated matches.
Wow. To account for the inherent randomness in soccer. A lucky deflection, a missed penalty, a moment of magic, things the basic stats can't fully capture. Each simulation plays out slightly differently based on the goal probabilities.
So it generates a whole distribution of possible outcomes.
Precisely. And from those 10,000 simulations, they can see which score lines pop up most often.
Okay. What were the most frequent results from the simulation?
The most likely scoreline was actually a 1-1 draw. That happened in 12.13% of the simulations.
Oh, interesting. So the draw is quite possible despite the classifiers favoring an away win.
Definitely. The second most likely score was 0-1, an away win for NYCFC at 9.8%, and the third was 1-2, another away win at 8.87%.
And what about a home win for DC?
A 1-0 home win was the fourth most likely scoreline, appearing in 8.39% of the simulations. So it's certainly in the mix.
Okay, so the simulations give us scoreline probabilities. What
Okay.
about the overall win-draw-lose probabilities from those 10,000 runs?
Looking at the overall outcomes, the Monte Carlo simulation calculated a 31.2% chance for a DC United home win, a 25.93% chance for a draw, and the highest probability, 42.87%, for a New York City FC away win.
Right, so even the simulation, which accounts for randomness and potential draws, still leans towards New York City FC winning, aligning with the classifiers, but showing draw as a solid second possibility.
Exactly. It gives a more nuanced picture than just saying away win.
Let's circle back quickly to that Poisson regression part.
Mhm.
The report had some summaries showing which factors were significant.
Yeah, the model summaries. They basically highlight which input features had a statistically significant relationship with the predicted number of goals after accounting for other factors.
What stood out for the DC United home goals model?
For the home model predicting DC's goals, things like the market's implied probability of a home win, the market's implied probability of the total goals being under 2.5, and the market probability of both teams scoring, BTTS, were all statistically significant.
So betting market signals about the result, the total goals, and both teams scoring seem important for predicting DC's home tally. What about for NYCFC's away goals?
For the away model, predicting NYCFC's goals, the significant factors included the market's probability of an away win, the probability of goals being over 2.5, the probability of goals being under 2.5, and again, the probability of both teams scoring.
Interesting how the market odds pop up as significant in both models for different aspects like over-under and BTTS.
It suggests those market probabilities are capturing something meaningful about goal expectancy. Yeah. And remember, the Poisson model itself doesn't just spit out one number. It generates the probabilities for scoring 0 goals, 1 goal, 2 goals, and so on for each team.
Right, which then feeds that whole Monte Carlo simulation process.
Precisely.
And we touched on the machine learning models, RF, XGBoost, MLP, and the report gave some accuracy scores, right, around the mid-50s.
That's correct. The report listed classification accuracy scores like 0.56 for random forest, 0.54 for XGBoost, 0.53 for MLP, based on their testing data. The stacked ensemble also hit 0.56 accuracy.
Now, 56% accuracy. That might not sound amazing to everyone.
Well, you have to consider it's a 3-outcome prediction. Home win, draw, away win.
Yeah.
Random guessing would be 33%. So getting into the mid-50s consistently is actually quite a decent improvement over chance in a complex sport like soccer. Plus, they mentioned using those techniques like SMAT and grid search specifically to boost that reliability as much as possible.
Okay, context is key there. Better than chance, and they're using standard methods to optimize. And the stacked model, the combined one, performed well too.
Yeah, achieving the same accuracy as the best individual model suggests it's effectively leveraging the insights from the different approaches. It's all about combining the statistical goal forecasting, the machine learning pattern recognition, and then simulating the randomness.
Okay, let's boil it all down. The bottom line. What is SmartBet AI's main prediction for DC United versus New York City FC on May 14th?
Well, synthesizing everything. The consistent prediction from all the machine learning classifiers, RF, XGBoost, MLP, and the stacked ensemble is an away win for New York City FC.
Cool.
And the Monte Carlo simulation supports this as the most likely overall outcome, giving NYCFC a 42.87% chance of winning. However, it also highlights that a 1-1 draw is the single most probable scoreline, 12.13%, followed by 0-1, 9.8%, and 1-2, 8.87% away wins.
So the AI leans towards New York City FC, likely in a relatively close game, maybe 1-0, 2-1, but a 1-1 draw is definitely something the simulation's flag is very possible.
That sums it up nicely. It's a data-driven forecast pointing to an away victory, but acknowledging the significant chance of a draw and the relatively narrow margins involved.
It really is fascinating to see the layers involved. It's so much more than just looking at the league table, isn't it?
Absolutely. It shows how far sports analytics has come using, regression, advanced machine learning, simulation, trying to model all these different facets of the game, from team strength and form right down to market sentiment and random chance.
Definitely gives you a new lens through which to watch the game, which kind of leads to a final thought, doesn't it? When you see all this complexity, all these models trying to pin down an outcome, how much can we really predict a single soccer match?
That's the big question, isn't it?
Yeah, with all the data, all the AI, how much room is left for, just pure chance. That one unexpected moment that flips the script entirely. It makes you think about that balance between predictable patterns and sheer unpredictability, not just in sports, but, well, everywhere.
A really interesting point to ponder. The data gets us closer, but maybe never all the way there.
Something for y'all to think about. Thanks for joining us on this deep dive.